Működik ez?
Okay. So hi everyone. I'm Szabolcs, but you can find me as Nets on Twitter. Recently I started a blog, nets.is, so I just write my ramblings there. Nem lett jobb. Ezt teszem a fülemre. Így? Hát ha.
Is it better?
Can you hear me? Sort of, okay. During my day job, I work as a senior engineer at IBM Budapest Lab. Recently, years ago, it was Ustream, but IBM bought us, so now we are part of the Big Blue. And when I'm not working, I'm at home or working on these two projects, JSConf Budapest and CSSConf Budapest. I'm sad to announce that this year we're going to have a pause. So this year there won't be a JSConf Budapest. That's it. And today I'm going to talk about an introductory talk. This is an introductory talk to DevOps, like the few things I really needed to know when I started to write my first Node.js microservices. And if I knew these things back then, that was really helpful for me. So I try to summarize it, and hopefully some of you will learn something of it, or you just enjoy the talk. So I'm going to talk about metrics, error reporting, logging, secret storage, service discovery, running and managing programs, and lastly, how services can communicate with each other. So first, let's talk about metrics. What are metrics? Simply as that, metrics are time-bound historical numeric data of some kind of a property of a hardware or a software or a network. It's like users currently logged into your service, memory consumption, network lag, even software complexity is a metric. So, and these are related to time. They are it's a historical data. So it is very good if you start to collect these metrics as soon as possible. You start to develop your application or your service, because it shows the backstory of your service. How do you implement? It shows the road you're taking. Metrics are great. It's a historical data. It can show you trends, like memory leaks. You can debug or plan ahead. It can show you quick changes, like what happens at releases. You can show you anomalies, like spikes or gaps. You can create alerts on them. You can analyze them. Is it periodic? Is it absolutely random? You can guess what's happening. You can really start to look into your systems like a higher point of view. And from the point of your service, the point of your app, it's really important how do you collect these metrics? How do you deliver these metrics? You can push data, or even better, you can let the metric service collect this data. Usually the services handling metrics collect it periodically. It's called scraping. And it's really simple. You just have to put your data, your metric data, where the collector can reach it, and it just takes it away from you. So from Node.js perspective, you just put your metrics on an accessible endpoint, like metrics or status. The metric service will come and collect it. There are very good libraries which can automate and instrument the HTTP library in Node, and they will create this endpoint for you with all the metrics, networks, lags, anything you want. And you can add other metrics later. And after this, just lean back and watch those nice graphs. That's it. Some key metrics, it's really important to look at these. And usually the libraries that instrument HTTP start to collect these metrics instantly is latency and resources. You probably know latency. It's basically the time needed to serve the requests that arrive at your service. And it's really important to check the latency, check for slow queries, create performance tests on them, iterate code, check, recheck, and retest again. So let's see how these slow queries start to get better. Another important thing with latency that you please do not use an average on latency, because if this is your latency graphs, like some of the requests are super fast and some of these really, really slow, if you take an average, everything is fine. But in real world, some of them is really good and some of them is very bad. So use a histogram like this, so you can differentiate. You can see which are the slow queries and which are the really fast queries, and you can focus on the slow ones. The other important metrics is resources, like slow memory leaks, what's happening, or your storage is getting full, so you can predict resource shortage and prepare for them, like get a new server, start to scale, stuff like that. The last thing about metrics is really important, that actually sending metrics somewhere is not the job of your application. It's not the job of your service. So please keep this in mind. You will see slides like this regularly repeating in my talk. The next topic is error logging. It's a very important topic. The first question is, when should we error report? Obviously, during production of your live service, what happens, instant alerts, everyone is awake. The next one is during feature testing. If you do feature testing, you can see, okay, we did something, it's bad. Not that bad because it's a new feature, it's not released yet, but you have to keep an eye on that. It's really important that if you do releases, keep an eye for error reporting, see the error reporting log or something. It's basically instant red flags that something is wrong. But the most important about error reporting is find the error before the user, because that's going to save you money. What should we send during an error report? Like the environment, where is happening, where is it happening in the code, custom data, anything that helps you debug. And what should not be sent is like secrets. So be careful about secrets or any sensitive data that's inside your error reports, because that's going to cause a leakage. It's very important. On the contrary to metrics, error reports should be pushed immediately when it happened, where it happened, and you have to prepare for the unexpected, handle the unhandled. And the last one is actually it's a backstory from a startup in Budapest. It happened with them. Implement some sampling, throttling, or timeout, because sending error logs too fast just gonna DDoS yourself and kill your own application. So please be careful with that. There are many tools to do this, like Airbrake. I prefer like Airbit because it's open source, free, and it uses the Airbrake API. Node has almost every, there's a library for every one of these in Node. And the other important part is integration. So, okay, you're collecting your error logs. There are servers that collecting your error logs, but you have to create integrations that notifies you, like PagerDuty, or you see it during daytime on Slack or HipChat if you use that. This is very important because it helps you escalate quickly and very fast. It helps your reaction very fast, reaction time, sorry. The next part, beside error logging, is logging. The difference between error logs are occasional and logging is anticipated. So you are prepared for logging, but you better be prepared for error logs. A good way to distinguish logs and from each other is context. I really like this tweet. So it's like, fatal is wake me up on 4 a.m. on a Sunday. Error is apologize to the user, raise a ticket. Warn, okay, let's call it, make a note in case this happens again. Info, everything is just fine. And debug, fill my C drive with logs. In context, the fatal needs instant intervention, check the error logs. An error, okay, inform the user, but check the error logs. Warn, escalate if it happens again. Info is just a step in a normal workflow, and debug is just if you need it. Use them wisely, because and use them where they are really needed. Because if every error is fatal, then none of it. So keep in mind. What are the benefits of custom logging or logging? Well, of course, debug. You can debug your code. And you can create and log custom events. So you can create user journeys for your product people, what's happening to your services. And this way, you can profile, do A/B tests, and you can actually help product development just by doing logging. It helps not just you, not just your application, but the product people, the UI, the UX people, everyone is happy. Logging in Node.js, I won't recommend you any library because there are tons of them, but pick anything that has timestamps, can do log levels, can be routed to standard output or standard error, even better if both, can be formatted, and can create or use a correlation ID. Now, this is important. What is a correlation ID in logging? When a user comes to our service, something happens, we create a correlation ID. That is an identification of this user journey, what happens, this request. We log this into our logging collecting server, and then this service starts to call other services, and we pass this correlation ID to those. And then those services start to call other microservices, and we pass the correlation ID to those. And all of these start to log down this correlation ID, and when we look at the logs, we can see this request that started from one user that went way all around our complete architecture, or complete stack. And we can see what happened where and where they went. And if anything is wrong, we can debug easily. Best practices to logging, just put it out to the standard output. Docker and Kubernetes really encourages you to do this. Pipe it out to a file if you need a log file, or whatever you need. It's really good if you can turn on debug mode runtime, like using signals. Never log secrets. Like hash them, remove them. Be very careful. Today is coming I don't know when the GDPR. Who knows this word GDPR? Raise your hand. Okay, so you know what I'm talking about. So be very careful with that. About secrets and personal data. Then you must not let it leak your services. And after this, just have to let the log collector handle the rest. There are tools like Fluentd, Logstash, syslog, ng, rsyslog that does this. Like they are collecting your logs, aggregating them into Stackdriver or Elasticsearch. They are both like Fluentd based. There are several other systems like this. Kubernetes has its own system like this. It's really useful, but you don't have to really get an immersed knowledge of this. Just prepare the logs for them. And sending the logs is not the job of your application. It's the job of your log collector and the log aggregation system. Now, I mentioned secrets a few times. Let's talk about secret storage. What is this? It's a really useful system, really useful service, and it can be used with a node really easily. What are secrets? Like passwords, usernames, okay, database names, yes. API keys, important because API keys are like the actual password to your services you use. And private keys like certificates and that. These are all considered sensitive data. Never store these in source code, private VCF repositories, because if you do it in a private, say, okay, it's private, someone does a fork to a public repository and it's done. Never put it in config files because config files usually end up in source code and repositories. Don't do it in simple database files because where are the passwords for those databases? And be careful with environment variables because they can leak through logging. If it's possible, use a managed secret storage system. There are several ones like Vault from HashiCorp, AVS has this KeyMS, Docker has one, and of course Kubernetes. What are the benefits of using this? Well, you can create policies, access lists, who can access which tokens where. It has a centralized key rotation, so if you have to change one password to all of your databases, you can do it in a single place. You can create single-use passwords. You can create n-use passwords, like use it at build time and use it on release, and that's it. You have to request a new one. You can create time-bound keys. You can use it for a few hours. You can create an audit log, what password, what credential was used, when. Just, okay. My sound got just bigger, sorry. And it is accessible during runtime. This way, there are no secrets stored on disk. Or it can be accessed during build time when your application is compiled before deploying. It's really simple how it works, despite what it sounds. So let's see. You have the version control system like Git, and there's the secret storage server in the middle. There are your application servers or your build server. So we are talking about build time or runtime accessing secrets. In both use cases, the source code arrives to this destination, and it's holding placeholders like secret hash name in your code. So not holding actual secrets, not holding actual tokens, something like that. It's just placeholders. During build, we can go to the secret storage server and get the secret name pair using a token stored on the build server and get the actual secrets. And this is the same during runtime. We can query the secret storage system using a token and these hashes and get the actual secrets. And then the code prepared with the secrets can be deployed to the application servers, or on the application during runtime on the application servers, the secrets are stored only in memory, so not on disk. And this service in the middle, it's a really powerful encryption. It's kind of superpower. It actually has to be unlocked when it starts. I'm talking about Vault now. And I don't know about the other ones, sorry. And this means that this server is useless and inaccessible without unlocking, even with a physical compromise of the server. Never store your secrets in your source code. Very important, please. There are plenty of examples of public searches on GitHub, like keys and passwords, and it's frightening, and the internet does not forget, so please don't do that. Let's move on. Service discovery. This is basically a great tool, a Swift knife of service-oriented architecture. Service discovery does several things, like register your services and notify other services about these new instances. Or it can help you for a service discovery. Are you looking for an instance of a service? It can help you direct you there. It can monitor your services. If a service goes down, it have to handle the rest, so handle the ones before it. So it's basically a simple monitoring that, okay, that service is not accessible or that node is not accessible anymore. And it can help you very much with load balancing, like direct traffic to a new service. How it works. Service discovery can act like a DNS. It's very simple, especially in an internal network. Or it can be used in a more complex way to create and write configuration files. But this way you have more control. Really simply put, how it works. We have an application server. We have some metric collection or log collector, and we have a load balancer. This server is booting up. The application is ready for service. There is a separate process on the server called the Service Discovery Agent, or SD agent. It checks some properties of the application, like the port, or the PID, or something, you name it. And if it decides based on these properties that your application is ready to serve, it notifies the service registry. It does this checking periodically, so if anything goes down, anything bad happens, it will always notify the service registry as soon as possible. Now the service registry knows about our service. A new instance has been created. So it creates configurations or notifies other services like log collecting or metrics and the load balancer. After this, it can start scraping metrics, or the load balancer can direct traffic to the new application, to the new instance of your application. It's really simple. The SD agent is a separate task, job, or process on the server. It can be configured what to check, and it's totally independent of your application. There are many services and agents for this, like Apache Zookeeper, Eureka from Netflix, Consul from HashiCorp, Doozer, or you can use etcd to work like this way. And needless to say, registering your service is not the job of your application. So don't ping from Node, service discovery systems, or anything like that. Let's talk a quick part about process supervision. This is basically how to keep your app working based on some property you define, like PID, ping time, HTTP response, anything, you name it. You can create separate scripts for this. It can fail after trying, so you can give up. I'm not trying anymore. And you can notify other services with this. Now, what it does actually restarts your service. So using a automation tool like this, it also comes with a few compromises. So if you have supervised processes, it instantly restarts. There are no downtime, very good. But sometimes you have to go down deep and check what the heck was the reason for actually for the crash. If you have good monitoring and good error logging, maybe you're saved. Or you can do it manually. The upside of this, that you can go into the server and debug. But this time, the mean time to repair can be really high. So like it can cause downtimes. It simply depends on what error logging capabilities you have and what actual needs you have in your service. A really, really simple tool for this is Monit. It's ages old. It can manage any process. It has a small footprint, and it's very simple. Well, in Node, tools exist like PM2 and Forever, and usually the cluster module is very good. But then you have to deal with restarts, health checks, failovers, and cross-process communication is not cross-instance communication. So how do you communicate with other services or other servers if you rely heavily on cluster module? And it can cause an operation overhead. So, okay, your cluster module is it handles all the communications with the node fork node processes, but that part of the CPU time is where to put that. So it's really, really, I don't know, it's a messed up story for me. Another slightly related thing is how to run programs, how to demonize programs. Program runners, they basically start and stop the processes. Watch the process and handle the state. And they can send signals to the processes. And these signals can do custom tasks. They are really useful. Some of these are run it, upstart, systemd, supervisor d. In general, if it's distribution independent, it's better because you can migrate your system anytime, anywhere. And the easier it is to config, it's the better. Personally, I really like run it because it's really, really simple to configure it, and it's like really a joy to use, actually. Now, speaking about managed services and supervised daemons, when I started to do this, I started using both, and it created weird race conditions. Like, if one of the services got restarted, which one caused it? It was the program runner, or was it the supervisor? I have to check logs, what happened, and then I realized that, okay, I will use the supervisor to tell the program runner when to do it and how to do it, and then the program runner will kill or run my application. They usually don't know about each other's state, so that is important. That use the demonizers to stop your applications, and the supervisor to decide when to start or when to stop an application. Lastly, just touching the topic of connecting services. About connecting services, what the goals are here are really simple. We want to decouple services, separate them, loosen up the connection between them, so we can scale easily when needed, or scale down after the load is down. And there are two ways for this. The one is very popular, the HTTP-based APIs, where we have a service, there's a load balancer, we have a second service, and the load balancer decides where to put your HTTP request. And if you spin up new nodes, we have to use a service discovery system I mentioned before to create a new configuration for the load balancer so it can direct new traffic. Or we can use message queues. When there is a message queue, we have one service just putting the messages into the message queue to be handled, and the other service picking them up and handling them and putting back the response. And this is very, very easily scalable because we have to just create new instances here. They instantly know where to go for the new messages, where to go for new jobs. Configuration is simple here. Both of them has benefits and downsides. HTTP APIs, they are usually appear as an open API. They can work really good as remote services. And they usually can work async and sync both, while message queues usually are asynchronous. They work very well when it's grouped or closed or a single network. And when this happens, it has very low latency. So it's really, really good. Really fast, actually. So I would like to close my talk with a few messages or stuff to learn. So you can prototype, learn, use whatever modules in your service you like, but get ready to go to live to production anytime, and get ready to scale easily because that's very important. You have to focus your application to do its job, not sending logs or registering services or anything else. Keep it simple. Keep the footprint minimal. And find your ops people, talk to them. They are actually here to run your application. They can help you a lot. Get on a common ground with them, and I hope after this talk you can ask the right questions so they can help you. Thank you.